Assalamualaikum everyone. My name is Muhammad Harid Mazuki. I'm from AS2452B and my ID is 2021393459. I will be talking about leaching for class 50 of CMT 405. Leaching is a type of solid liquid extraction that have liquid dissolved solute from a solid mixture. The main function of leaching is to extract product from solid mixtures such as ore in oil plants. It is used extensively in metallurgy, agriculture, and chemical industry. Leaching works by adding liquid to a solid mixture. The liquid and the mixture then left alone for a long time or agitate to dissolve the solute or suspend the insoluble. After that, the liquid with rich solute content and the insoluble solid will then separate to collect the extract. There are several factors that may affect the leaching process. One of it is the solvent. It is important that for the solvent to have a high selectivity and high saturation limit. For this will ensure that it will recover have a high amount of solute with little to no purity. And then another factor that may affect the leaching is temperature, when the temperature increases, the kinetic energy of the molecule increases, which allows the solvent to quickly dissolve the solute. However, some extraction are temperature sensitive and it may affect the liquid's ability to extract the solute. Thus, it is important to strike a balance in temperature in order to have an optimum extraction process. Another, apart from that, we have the pH of the solvent, which will it allows a faster it's accelerate the rate of dissolving solute and improve the and it may will help with the selectivity of the liquid. This can be observed in the metallurgy metal ore extraction. There is several type of leaching. One of it is batch leaching, where the leaching and where the feed and liquid were added once. The liquid of the volume of the liquid is fixed in under this operation. Neither the liquid nor the feed leave the system until the operation ends. This will this type of leaching yields a high recovery rate, but it will take a long time to operate. And then we have the continuous leaching, where the liquid and the feed cycle repeatedly in the system. Both will continuously enter and leave the system while under operation. Under continuous leaching, there is concurrent leaching that have the liquid and the feed move at the same direction. This will yield a sol- this will yield a solvent that has equal amount. The sol the solvent will extract the solute from the feed until both of them have the equal amount of solute. And then we have the counter current leaching under continuous leaching, where the movement and of the feed and liquid are in opposite direction. The this leaching has two conditions to consider. We have constant underflow, where the amount of solvent that are leaving that are in the insoluble solid after leaving a unit is constant. Therefore, the amount of mass leaving a unit is equal to the mass entering a unit. And then we have the variable under constant, the amount where the amount of solvent that are insoluble solid after leaving a unit is not consistent. In this case, to determine the mass entering and leaving the system, it is necessary to find the ratio of solute amount to solvent amount. There is several process and equipment that relies on leaching, such as percolator, the Bowman type extractor, the horizontal basket design, endless belt percolator, Kennedy extractor, dispersed solid extractor, screw conveyor extractor, the Hildebranch total immersion extractor, the BMA diffusion tower, and tray classifier. One for one, we have the rotocell extractor that is a horizontal bucket that uses the horizontal bucket design. This extractor has a rotating sector for even distribution of the feed. The floor are perforated except for one sector that is open to a feed discharger. A fresh solvent will enter the sector that is before the discharger, depending on the rotation of the sectors. This extract will then cycle through another sector until it eventually has a high amount of solute, and it will be extracted out of the system. The fresh feed is added after the feed discharger. Well, and then after the feed is exhausted, it will be disposed at the feed discharger. Mm, This will this type of design will yield a high amount of solute, and it's pure and remain with high purity. However, the solvent used is expensive, and it's not very safe to use because it's very toxic and flammable. That is all I can that is all I will say for leaching. Thank you for listening.